Welcome back, students. My name is Dolun Banerjee and we were continuing with our geotechnical engineering series of video lectures. Okay, so we have completed the index properties. Okay, now to check how much we have understood, let's go to some numerical problems based on those numerical index properties, and also let us use the procedural concepts in the numerical problems. Okay, so let us see how we will be doing that. Okay. So first of all, just solve the problem. Main objective this time is solving the problems based on the numerical properties. Okay, so let us move forward. The first numerical property or the first index property we will be using here will be dry density. Okay, this is based on the dry density. What is the question? Let us see. A sample of clay was coated with paraffin wax and its mass, including the mass of wax, was found to be 697.5 grams. What does this mean? First of all, you have a, say, suppose a sample of soil, something like this. Okay, this is coated with a layer of paraffin wax. Okay, you know what is wax. Okay, this is coated with wax. Then the mass is taken. Okay, its mass is taken, which comes out to be 675. Sorry, 697.5 grams. Okay, to here we have understood. Then the sample was immersed in water and the volume of water displaced was found to be 355 ml. What does this mean? This whole paraffin waxed soil is immersed into liquid. Okay, suppose this is liquid. Okay, now how much water it displaces? 355 ml. What does this mean? This is the volume of total mass. Okay, means soil plus wax or paraffin wax. Total volume is this much. Okay, and what about this? This is actually your total mass, means this is mass comprising of the paraffin wax and the soil. Okay, this is total mass and this is the total volume. And then the mass of the sample without wax was 690 grams. This was with paraffin wax. Now without paraffin wax, it is given that is only of soil, that is given to be 690 grams. Sorry, (690 grams). Okay, so this is it. This is the total and this is for soil only. Now the water content of the representative specimen was 18%, means some part of this soil was taken and oven drying method was used or some other method was used to find out its water content, which came out to be 18%. Okay, determine the bulk density, dry density, void ratio, degree of saturation. A specific gravity of soil solids is 2.7 and that of wax is 0.89. Okay, so this much data is given. For soil it is 2.7 and for paraffin wax it is 0.89. Okay, this is the whole part, or this is the total question. We have to find what? Bulk density, dry density, void ratio and degree of saturation, that is S. Okay, so let us see how we will be doing this. First of all, the first step was to get what are the things given to us, which we already have seen. Now the second step will be finding out the mass of the wax. How? Obviously this was the total means paraffin plus soil, and this is only of soil. So when we will subtract them, we will get the mass of the, this is mass of wax. Okay, then volume of wax. How we will get the volume? We are given with the specific gravity, or that is 0.89. Okay. Remember one thing, the value of gamma w or sometime rho w is equal to 1 when this is written in the gram per cc. It is 10 or 9.81 when it is written in kilonewton per meter cube. Okay, remember this, this is important. Okay, so in this case you can see we are moving in gram and ml only. So what will be the value of rho or this will be 1. So this is used here. Okay. So what will be specific gravity of this paraffin wax is given to us to be 0.89. So you know what is the formula? Gamma for paraffin wax upon gamma for W. Okay. We require the volume of wax. So this, let us bifurcate it into weight of P upon volume of P. So finally what we will get? Volume of P will be equal to weight of P upon G of P into gamma of W. This formula is used here. Weight of P, this one, gamma of W is 1, okay, and this is given as 0.89 in the question itself. So we will get this is the volume of wax. Then let us move on to the next step, that is the volume of soil. How we will get the volume of soil? This is very easy, because when we immerse this in the water, we found this was the total volume, okay, total volume when we immersed in the water. Now volume of wax is being calculated here. So if we subtract them, we will get the volume. You can see this is ml and cc equal. Remember, in case of water, in case of water, ml is approximately equal to cc. Okay. So we directly written them from here to there. So now bulk density. What is bulk density? We will be using total volume or total weight upon total volume. This is bulk density, gamma b, or you can say rho b. Okay. So in this case, this is the total weight of the soil, okay, which was given in the question, and this is the volume which just now we calculated. So W by V, this is your answer for bulk density. Okay, so one part is completed. I think you have understood. So let us see how the other parts are calculated. Dry density. Now what about dry density? Dry density, what is the formula if you remember? Gamma d or rho d is gamma b or rho b upon 1 plus W. This is given out 18% in the question. This we just now calculated, so we can find this. So the same is done here also. Okay, we get the answer as 1.69. Remember, this is going on in gram per cc. Okay, how we convert from 1 gram per cc is equal to 9.81 kilonewton per meter cube. Remember this relation as well. Okay, this is also an important one. Now finally we are to find the void ratio E. Okay, E and S, two things are now remaining with us. So what we will do, first of all we will find out E. How we will find out it? You remember perhaps the formula gamma D is equals to GS gamma W upon 1 plus E. Just now you find out the dry density, gamma W you already know. So this is the formula which we have used, 1 plus E, sorry, let me clear it. Okay, so 1 plus E is equal to GS gamma W upon gamma D. So the same is used here. Finally we get this one. After 1 we have subtracted here, we will get E is equals to this one. Once we get E, you remember the formula, S into E is equals to W into GS. Now we know this, we know this, we know this, so this can be easily calculated. So the same formula is being used here. So we get, remember, degree of saturation is generally reported in percentage, so it is 81%. So this was your first question. You can see that we have used the general relations within these calculation of these parameters. Also we have used the physical behavior of this. Okay, physical behavior meaning that we have calculated the volumes. Okay, we have calculated the volumes by understanding that how can we calculate it physically by reading the question or dealing with the question. So first of all you have to understand what is given in the question and how can you relate it to find out your answers, because formulas are the later part. First of all you have to understand what is given and what is to be found out. Okay, let's move to the next question. Now this question you can see is based on sand replacement method. Okay, so let us see. There are a number of parameters given to us. During the site investigation for residential complex site at Roorkee, the following observations were taken: in situ weight measured by sand replacement method. The first one is weight of excavated soil. Okay, this is the soil which was excavated from that borrow. Okay, then sand plus cylinder after pouring in the hole and cone. This is sand plus cylinder after pouring in the cone only. Okay, and this is the calibrating can's volume. Then weight of the sand in the calibrating can after pouring in the cylinder. So these are all values given to us. Now what we have to find? The in situ density. Okay, we have to find the density of the soil in the ground or of the field. Now you can see weight of the sand filling the excavated hole and the cone. Okay, so you know total weight or initial weight. Okay, and after that we have the weight. So this much sand, this much sand was actually used up for cone plus the second thing is the hole. Okay, cone plus hole. This much sand or this much amount or weight of the sand was used to fill up the cone and the hole. Okay, then only cone if we are to find, what we will do? We will subtract second and third readings, means hole plus cone was there and one was only hole. Okay, so this will give you cone only. This was to be this. So finally if you want only hole, how much the sand was constituted in hole only? To find this, what we will do? We will subtract these two. Okay, this and this. So in whole how much sand was there? We can find out like this, 605 grams. Okay, so now we have the amount of sand or weight of the sand which we took to fill up the hole. Okay, so now let's move on. Now unit weight of sand. You know that for unit weight of sand, what we want? This is the volume. Okay, volume of the can. And what is this? You can see here the weight of the sand in the calibrating can after pouring is given to us, and also volume of that calibrating can is also given to us. So just we can divide this W by V to get the sand's weight. Okay, unit weight. So we have done the same here. This comes out to be 1.55. And volume of hole, how will you find out the volume of hole? If you remember, this is the mass, okay, of the sand which was used up to fill the hole. Just now we calculated in the previous slide. So this is the mass, and we know the dry density or the unit weight of the sand which we have calculated here. So upon this will obviously give us the volume of hole. Okay, so this is what we calculated here, and which comes out to be 390.32 cc. This is cubic centimeter. So final, the in situ weight, how we will calculate the in situ weight? Again W by V. This part is already given in the question, and this is just now we calculated. So we get out to be 1.99 gram per cc. Okay, you can see here that this is given already, so don't get confused. We are given with the weight already, just we had to find out the volume, which we have found out, and now we get our answer as 1.95. Okay, so this was one easy question based on sand replacement method. Okay, so now let us go to the next question, numerical on liquid limit method. Now this is on liquid limit method. Okay, if you remember, what we had done in the liquid limit was that we first of all found a number of blows, different number of blows and corresponding W. Okay, number of blows and corresponding W was calculated it in the semi-log. Okay, semi-log graph. semi-log graph, something like this or whatever may be the shape. Okay, this will be N number of blows and this is W water content. Okay. So, what we have been given now, let us see the result of the liquid limit test are given as number of blows and water content, determine the liquid limit. To find out the liquid limit, what we have to do, we have to plot this graph in this semi-log. Okay. Only then we can find out the liquid limit corresponding to these practical values. Okay. Otherwise, we cannot find out. So, first of all we will plot the graph. Okay. Then what is the second question? Plastic limit is to be 23%. Find out plasticity index, flow index, toughness index. Okay. Hence, comment on the nature of the soil. So, let us see, first of all let us plot the graph. Here you are given the graph. Okay. A curve between the water content and the number of blows is plotted in the semi-log graph paper. Okay. W and log 10 n. The water content corresponding to 25 blow was obtained to be 43. You can see here, this is something like this and something like this. It comes out to be 43 and this is your 25. Remember, according to 25 only we find out the water content, which becomes our liquid limit. So, here this is our liquid limit 43%. See, this is the liquid limit. Okay. Now, we were given with the plastic limit in the question and liquid limit we have found. So, IP, what is IP? WL minus WP. So, we can just subtract both of them to get 20% as the plasticity index. Okay. Then we have to find the other indices such as flow index. What was flow index? Flow index was as this. What is this formula? IF W2 minus W1 upon log base 10 N1 by N2. Okay. This was the formula. So, we have used it here. Let us see. Here you can see what are the parameters here, 52.8 and 32.1 and 48 and 14. Okay. So, 52.8 means this, okay, and 32.1 means this. Correspondingly, what will be the n value? This is taken as 14, okay, and this is taken as 48. Okay, you can see 48 and 14. So, this was your calculation. You can actually, it is a straight line. Okay, you can see there it is a straight line. It's a straight line. So, you need not take only these points. You can take any point here, any point here. You can take a point here, and also then also you can calculate the same flow index, and the answer will be same. Okay, because it's a straight line. You can do with others also. Finally, toughness index. Toughness index IT, there is IP upon IF. Okay, means plasticity index upon flow index. Both of them you already calculated, so directly you get the answer. It is okay. Now, if you remember the chart for plasticity index, since the plasticity index is greater than 17, okay, so the soil has high plasticity in nature. It is highly plastic. Okay, this soil is highly plastic. Toughness index is less than 1, so it is friable. Okay, at liquid limit means it can be easily crushed. Easily crushed. Okay. So, this was it about this question. Okay. You can solve a number of problems likewise, so that you can get your concepts clearer. Okay. This is it for this class. Next class also we will be solving some more problems, so that some other indices, index properties are also covered up into the numerical part. Okay. So, we will be continuing with this later on. Keep watching the videos. Thank you.